Hi guys, this is the second go around and I've already filled in some blanks because there's so many distractions going on that had to start over. Okay, so let's start over. So we're talking today about plate tectonics and how these lithospheric plates, these huge plates, are moving. They are moving in different ways, and we'll explain how in a minute. But what is plate tectonics? It's the interaction of the Earth's rigid or stiff rock plates as they move slowly over the asthenosphere, those convection currents in the asthenosphere or in the mantle. So what evidence do we have? We already have fossil records from Wagner. We also had seafloor spreading from Harry Hess and Fred Vines. They noticed that in the middle of the ocean floor, the plates are moving away from each other, so that gave us seafloor spreading. We also know that volcanoes, earthquakes, and mountains are also evidence of plate tectonics and the large lithospheric plates changing over time. So what happens when these plates move? Well, the Earth's surface slowly changes. And what do we mean by that? It changes about this much per year. So they move at about a rate of 3 centimeters per year. That's it. What happens? Well, they can create and destroy ocean basins. And we'll talk more about each of these as we learn more. They can produce earthquakes and volcanoes, and they can form mountains and plateaus. But anytime you need to pause this video to look over what I've already written, please do so. I'm just going to keep going till I start writing again. So here we have convection currents that are underneath the lithospheric plates. These are supposed to be the lithospheric plates here and here. And if you look at my convection current here, so warm, here's the mid-mantle with this is the asthenosphere. If you can't read that, that's okay. So it's not a big deal. But here's the asthenosphere and here the actual lithospheric plates, like the North American plate or the Eurasian plate, whichever one. So we have warm ooey gooey magma in the asthenosphere rising. Right, it's rising here and here. And if you can see the motion of how it's rising, it's going this way, which is actually moving plates apart and creating new magma in the middle, or letting magma create new oceanic crust or crust, period, in the middle. So like I said, they move very, very slow. And over here in this image, we have where the convection currents along a plate boundary where two plates meet up. This is actually where the stuff is cold and it's sinking. So this motion is bringing the plates together, if you can imagine that. So these currents are moving the plates like on a conveyor belt. If you've been to the grocery store, so the conveyor belt brings the groceries up to the cashier. Well, depending on the motion of these plates, if they are of the asthenosphere of these currents, if they are coming together, the plates will be coming together. If the asthenosphere, the ooey gooey magma within, is moving away along a boundary, then the plates will be moving away. And if it's sliding or moving in different directions, then the plates will be moving in different directions as well. So I added to mine that convection currents in the mantle drive plate motion, and they move plates like a conveyor belt. So we understand that it's moving these rock slabs, these grand lithospheric plates, like a conveyor belt, depending on the motion of the currents inside the asthenosphere. Okay, there are 3 types of boundaries, and there's boundaries where the currents, like we just said here, are coming together, so the plates are coming together, and we call that convergent. Or coming together. And when we have this type of boundary, we're going to see the effects are going to be volcanoes, mountains, earthquakes, islands, building, and deep ocean trenches. So we're going to learn about how all of these are formed along a convergent boundary. Then we have boundaries that are referred to as transform. These boundaries actually slip and slide, so they slip or slide past each other. And as they slide past each other, they create mainly earthquakes. That's something that we'll talk about. That's like in California. We have those earthquakes along the San Andreas Fault. That would be a type of transform boundary. Next type of boundary we have is called divergent. In this type of boundary, we have plates moving away from each other or moving apart. In these types of boundaries, you're going to see what's known as a rift zone, mid-ocean ridges, and seafloor spreading. So that would be the three types of boundaries that you can see. Once again, coming together. So they come together, they move away, or they slide past each other. All right, so what happens at a convergent boundary? What happens to the crust? Because students always ask, well, what's going on? Why doesn't the surface get bigger and bigger? Because we are creating crust in some areas. Well, in other areas, we're destroying crust, and that's why the surface never gets any bigger, or the crust never overtakes the surface, so to speak. So here, crust is destroyed. Along a transform boundary, crust is not destroyed or created, but it's transformed, right? If you have a road along a boundary that's like this, and then one moves like this and the other in the opposite direction, you're definitely going to have a transformation on the surface of some sort. So, but crust is neither created or destroyed. It just looks different. Okay, and then we have along a divergent boundary, crust can be created or is created. It is created. All right, so there you go. That's the three types of motion you can find along boundaries. Now, what am I talking about when I say along boundaries? Any place two plates meet up, all of these lines where two plates meet is a boundary. So you can see here I have motion arrows on this map. So I know here these two plates are moving away from each other. That means they are divergent, right? Because they're moving away, they're diving away, moving apart. I can look here and I can see that the arrows are pointing to each other. That means they are coming together or convergent. So these two plates the Eurasian plate and African plate here are coming towards each other. And I can see here they're convergent. And let's look. If you could look closer, this is more for here. And here we have two plates kind of moving apart. There's another small plate in there. So sliding past each other. So these two would be an example of transform in California. We'll talk more about that as well. So that's anywhere two plates meet up, the lines are boundaries, and that's where the motion occurs along these boundaries. All right, once again, convergent, transform, or divergent. We'll look at each one of these individually in the next few days. So remember, what is Pangea? Well, Alfred Wegener discovered that 225 million years ago, the Earth had a supercontinent made of all the curtain continents joined together. And plate tectonics is the theory that explains how they broke apart and moved to their current positions. Just a side note down here for earthquakes. Earthquakes are actually possible along any boundary. It doesn't have to be just the transform boundary or the convergent boundary. Any boundary where two plates meet, you can have some earthquakes. The most severe earthquakes do occur along transform boundaries, though. All right, that's it for today. Y'all have a great day. Bye.